A researcher plans to carry out a statistical investigation to test whether there's a linear correlation between the time, t weeks from conception to birth, and the birth weights, w grams, of newborn babies. Why is it appropriate to use a one-tailed test? So we expect the longer a baby is in the womb, the heavier it's going to be as it continues to grow, rather than the other way around. Rather than the longer it's in, the smaller it will be. So basically, just you need to say something along those lines. I simply wrote we expect there to be a positive correlation. The mark scheme referred to these sort of other things I've been saying. Like we expect that the baby to be heavier as the longer it's in the womb, which is essentially the same as what I've written here, just given context. It's an interesting question, and I did stumble across a paper once basically saying like you should always do a two-tailed test unless you expect this sort of thing. But this is definitely one scenario where you could definitely say, yes, it makes sense to do a one-tailed test. So let's do this one-tailed test for the product moment correlation coefficient. H naught is that rho is equal to 0. This is the population product moment correlation coefficient. That's what well, no, sorry. We're actually trying to then show that rho is greater than 0. One-tailed, we've got this 1% significance level. So in A level, we don't do any calculations to get the critical region. We're given them in a table. Um, It's a very short topic, but it's worth just bearing in mind, linking it to the normal and the binomial and how we found these are critical values. For those, it's done in a similar sort of way. So for us, because it's the 1% significance level and we've got 11 babies and it's a one-tailed test, then it's going to be this value here. That is our critical value. And we've, for our sample, got 0.722. So that is greater than the critical value. And in the same sort of way as I'm only drawing a normal here to compare. So you have a critical region here. If you end up in the critical region, then you reject H naught. So this 0.722 is beyond this critical region. Actually, I should probably draw it. So we've got from -1 to 1 and 0 here. And then what we're saying is if we have a one-tailed test, 1% significance level, sample of 11, then 0.6851 is the critical value. Anything that then lies in here is in the critical region. So it's greater than, it is in the critical region, and therefore we're going to reject H naught. Conclude that there is a positive correlation, or that as T increases, W increases.